Welcome back to this series of videos on learning from the core practicals. Today's experiment we're going to be investigating inks. But before we start the experiment, let's have a look at the reason behind this experiment. What is the purpose of this practical? Ink is a mixture of coloured substances dissolved in a liquid solvent. Ink that appears to be a single colour, such as black, might actually contain two or more substances with different colours. Simple distillation can be used to separate a sample of the solvent in some ink. Paper chromatography can be used to separate the coloured substances in samples of ink. So simple distillation can be used to separate the solvent, the liquid, from the solution. Heating the substance allows you to separate it, as it will have a different boiling point to the solutes in the solution. And finding the boiling point can help you identify the solvent. That's a good thing to remember. You could be asked about this in your exam. So for example, if the boiling point is 100 degrees, then the solvent is probably water, because the boiling point of water is 100 degrees. Okay, so I'm going to now talk you through the simple distillation that you can see is happening here. I'll talk you through the points you need to know for your exam and explain what is happening in simple terms. So here we have our solution. Our solution is comprised of two things, a solvent and a solute. The solvent is the liquid that has something dissolved in it, and the solute is whatever has been dissolved in it. And our solution we have here is ink and water. So step number one, we're going to be separating our solvent based on its boiling point. Okay, so our solvent is water, and step number one that you need to mention is we are heating it. We're doing that with our Bunsen burner here. Okay, now as you heat it, the change of state that's going to happen, our liquid is going to change to gas. That is evaporation. That's what's happening here, evaporation. Okay, and it's going to evaporate at 100 degrees because that's the boiling point of water. That's why we have the thermometer, so that you can measure the boiling point. So that liquid is changing to gas, it's evaporating and rising, and it's going to be collecting in this chamber here. This is called a condenser. And what happens in the condenser is a change of state, condensation. So in order to condense something, we have to cool it, and that's why we've got cold water running in and out, so that we're cooling this chamber. And that means that as the water rises and is changed to a gas, we're going to be turning it back to a liquid in the condenser here. And what you will eventually start to see happening is the pure water dripping down and collecting in our beaker. Okay, so that's the main points that you want to see here. And you can see it definitely is evaporating. I can see the bubbles starting to form on the sides of the glass. Condensation is happening here. And we will measure the thermometer, measure the temperature. It's almost at about 100 degrees. So we should eventually start to see water dripping down into our beaker. So as you can see, we've got pure water dripping down now. You can tell it's pure water, it's not the blue ink, it's just pure water coming through. That's because it is evaporated at 100 degrees, condensed back, and we now have the liquid water dripping down. The liquid that we call, that is separated by distillation, we call this liquid distillate. So if we were separating a different solution and it wasn't water, whatever this liquid is that comes down here, you can call distillate, and that will get you the mark in your exam. Okay, let's try some exam style questions based on distillation. So you could be asked something similar when you come to do your chemistry exam. A student carries out simple distillation on a sample of blue ink, just like you saw me do today. Predict how the appearance of ink changes and give a reason for your answer. That's worth 2 marks, so make sure you give your prediction and the reason. B, explain the function of the cold water that is running in and out of the apparatus. That is worth 3 marks, so make sure you've given 3 pieces of information there in your answer. Now please pause the video and have a go at the questions. Welcome back. Let's have a look at the answers. Let's see how you did. So A, predict the appearance and give a reason. So the appearance, the liquid should be clear and colourless. The liquid dripping into the flask will be distilled water. Okay, so your prediction is that it's clear and colourless, and the reason for that is that it's distilled water, which is the solvent in ink. Question B, explain the function of the cold water that is running in and out of the apparatus. So the reason for this is it allows the substance to cool and condense. That gets you a mark, which changes back to liquid state. That will get you another mark. And so it can be collected. That gets you your third mark. Well done. Have a go again if you didn't get full marks. You can have a look back at this as many times as you want. Let's have a look now at another method of separating substances, simple paper chromatography. Chromatography is a method used to separate a mixture of soluble substances and identify them. Now remember, the word soluble means can dissolve. So paper chromatography can only be used to separate substances that can be dissolved by a solvent. In paper chromatography, the paper is called the stationary phase. The solvent is called the mobile phase. That means the molecules can move when they're dissolved in the solvent, whereas when they're on the paper, it's called the stationary phase. They're not moving yet, they're stationary. Okay, so the first thing we're going to do is we're going to draw a line in pencil onto our chromatography paper. So this is our chromatography paper. It's what we're going to be making our chromatogram on. It doesn't actually matter exactly where you start it. You don't want it too far down. So I'm just going to draw a line in pencil across the chromatography paper. Now there is a reason why we do this in pencil, and that's because the pencil line itself is insoluble in water. So it means our pencil line won't affect our results. It won't be dissolved in the water when we dip it in. Okay, now we're going to add the dots of colour. We're going to be separating the ink of 3 different colours today. So we're going to add onto the line itself a dot of blue ink. A few dots on top is fine. We're going to add some red. And we're going to add some green. And we're going to use chromatography to separate the inks that we have present in each of these 3 different coloured inks. Okay, so at the moment this is our stationary phase because the ink is not moving. It's on the paper, on the chromatography paper. That is our stationary phase. So now, as you can see, I've clipped our chromatogram, our chromatography paper, onto just a little stick so that we can hang it over on top of our beaker. At the moment, if we were to hang that there, nothing's going to happen. We need to add our solvent. Now here's an important point that you could be asked in your exam. The solvent needs to be below the line, the pencil line, so that it doesn't affect our results. If we were to pour our solvent above the line, what would happen is our dots would just instantly dissolve and we wouldn't be able to separate them using chromatography because it would be dissolved into the liquid itself. So we're going to pour our water into our beaker. The water is our solvent. If you get asked about other solvents, don't worry, it's the same process. Solvent is just a liquid that is going to dissolve in. So this is just trial and error. We do not want the water line to come above where we've dropped the ink. And we're just going to hover that inside there and wait for the solvent to travel up the paper. And as you can see, the water is slowly moving up the chromatography paper. The dots are not touching the water itself, just the edge of the paper is, and it's slowly travelling up. Be very careful as you wait for this to happen. You need to make sure that you stop the experiment before the water reaches the edge of the paper. We don't want the water coming all the way off the top, because if you remember for our calculation for RF value, we need to do the distance travelled by the solvent, and if it's left our paper, we won't have a result there. Okay, so you can see now the water has reached the solute and it's starting now to travel up the paper and separate these into different coloured inks. So we are now in what's called the mobile phase. The solvent is now allowing the solute, the colour, to travel up the paper. Okay, so as you can see, the solvent's travelled up. It was actually continuing to run for these two here, but we've stopped it for now because we don't want the solvent running off the edge. So we can see the blue dot, we only had blue dye in the blue ink. The red dot has travelled, we only had red dye present in the red ink. But in the green dot, you can see there was definitely some blue and possibly some yellow in there as well. The only one that we can possibly calculate RF value in this one, because these haven't finished running, we'll do the RF value of this red one here. So it's the distance travelled by the solute, so that's the distance travelled by the red ink. So that is to here, and that is 6.8. So distance travelled by the solute, that was 6.8 centimetres, and we divide that by the distance travelled by the solvent, so that is the water. Now you do have to measure this quite quickly because you don't want this solvent to evaporate. You need to be able to see the water line. So you can see there 7.2. Okay, so 6.8 was the distance travelled by the dot. 7.2 centimetres was the distance travelled by the solvent, and if we pop that into our calculator, 6.8 divided by 7.2 equals 0.94 is our RF value for the red dot. Okay, so let's do some exam style questions based on chromatography now. Propanone is a flammable solvent. A student carries out paper chromatography of ink using propanone. Now don't worry about that word propanone. Lots of students, from my experience, might get a bit worried because they might have not recognised that word before, but it tells you it's a solvent and it tells you that it's flammable. So it's telling you the information that you need to know based on this question. You don't need to know anything else. Identify the mobile and stationary phase in the experiment. Explain one precaution necessary to control the risk of harm in this experiment. Suggest an explanation why the level of propanone must be below the ink spot on the paper at the start. Have a look at these questions and pause the video now to have a go. Welcome back. Let's have a look at the answers. Question 1, the mobile and stationary phase. So the mobile phase was the propanone because that's the solvent that allows it to move. The stationary phase is the chromatography paper itself. It doesn't move along the paper without the solvent. B, one precaution, well, it tells you it's flammable. There's a big clue there. So keep the propanone away from naked flames. There might be some other precautions you could give there. For example, make sure you don't drink the propanone, make sure if you smash the glass that you don't pick it up with your bare hands, but the most obvious one given to you is the word flammable, so I would go with that if I was you. C, suggest an explanation why the level of propanone must be below the ink spot. It's to allow the solvent to travel up the paper and to prevent the ink from dissolving in the solvent in the beaker at the beginning, because that would just make a big mess and it would ruin your results. Well done for listening to these different separation techniques. Feel free to have a go at the questions as many times as you want, or have a look at any of the other videos that have been uploaded onto the school's YouTube channel.